I am above darkness. I am somewhere really scary. This right here, ladies and gentlemen, is a brown dwarf. Today we're going to be talking about the Nemesis Hypothesis. The idea that somewhere out there in our solar system there is a brown dwarf that is actually causing a lot of extinctions on our planet every once in a while. Welcome to What the Math. So currently I am in Space Engine and I found this really dark brown dwarf that is just absolutely terrifying. This is actually super scary. You can actually try to go on its surface and you'll realize that everything goes dark. Like you have absolutely nothing here. Now this is basically a star that never really materialized to be a star, and I think I'm stuck in darkness now. Here we go. That actually was supposed to become a star but just didn't have enough mass. And this one is actually happens to be a dual star. It has a partner right there. They do appear red from a distance, but in reality this just kind of represents the infrared spectrum that they do emit. In reality this object is actually completely dark. You would not be able to see it in space, and if you're flying in a spaceship you would most likely collapse into it. So these don't always look like that. Sometimes they look like this, a slightly brighter version of a gas giant similar to Jupiter. Now this is actually even, I guess, more terrifying because it kind of looks like blood. Now this one has a name. This is actually the closest brown dwarf to us currently, and this is called Luhman 16, Luhman 16, and it's an object that's about 16 light years away from our planet. Now it kind of does look like this in real life because it does emit a little bit of light, and it does have a temperature of about 930 degrees Celsius. So it's pretty hot here. Whoa, this is crazy. This is crazy scary. Anyway, so this is the surface that I didn't actually expect to have, and this is things I'm learning. This is actually really unusual. Anyway, so it probably doesn't look like this because it is a gas giant, but interesting that the game does generate a bit of a surface here for this particular object. So the reason we're talking about this is that there's a hypothesis, there's a theory. No, it's not a theory. It is a hypothesis because it's technically not really proven. That there is an object similar to this called Nemesis in our solar system. And the reason why people think that there is such an object is because every 26 million years or so, specifically every 27 million years, there is actually an unusual increase in extinction events on our planet. For the past 500 million years, many creatures died every 27 million years. And the reason that scientists think this happens is because there's possibly an object similar to this that comes relatively close to our sun and causes a lot of comets, a lot of asteroids to change their direction and basically smack into our planet. And today we're going to use Universe Sandbox 2 to try to see if this is true or not, and also we'll talk a little bit more about the science behind it. So let's actually switch to Universe Sandbox 2. So let's try to investigate this hypothesis using Universe Sandbox 2 and see if it actually makes sense. Now, first of all, let's talk a little bit about the reasons why we think that there is possibly an object. So, except for the fact that there's possibly an extinction every 27 million years, one of the main reasons that people think maybe there's an object somewhere in the outer solar system is because of objects like Eris and specifically Sedna. Now, Sedna is really interesting here. It's really the orbit of Saturn that's kind of intriguing, because if we were actually enable orbits here, you'll notice that well, actually, that's probably not the best example. So just remember where Sedna is in terms of orbits. Notice how it's a little bit outside of the orbit of everything else. I'm going to go into simulation called solar system. Solar system all possible dwarf planets. So this includes all possible dwarf planets we've recently found. Notice how most of them are in this sort of a ring around our sun. And one of the reasons why most of them are in this particular orbit is because of Neptune. So Neptune kind of propelled them into this orbit and made sure that they stayed there because it's massive enough to actually influence these dwarf planets. Now their orbits are slowly disappearing. We can actually re-enable them by putting this here. And so this is kind of what it looks like. Now there are a few objects that are outside of this boundary. And of course, the one we're looking at right now, the one that kind of is of most interest to us is Sedna. Sedna is the outsider. It's sort of here It's far enough from our sun not to be actually influenced by it, but it's also not far enough from our solar system to be influenced by other stars. So what is it actually doing here, and how did it get here? And this is actually a really important question. The reason why we actually think maybe there is an object somewhere in the outer solar system that has a relatively big mass is because Sedna shouldn't really be here. If it was kicked out by Neptune, its orbit would be along with the other dwarf planets, sort of where Pluto is and where a lot of the other objects like Varuna and Orcus and so on and so forth. All of these other dwarf planets, they're in this sort of ring. And there have been a lot of propositions for possibly Earth-like planet somewhere on the outskirts that we don't see yet, or possibly a very, very massive gas giant somewhere even farther away that caused Sedna to be where it is. And actually, with the recent discovery of even more dwarf planets that are even farther than Sedna, it sort of gives us an idea that maybe there is something out there. But one of the more interesting theories is, of course, the theory of Nemesis, and we're going to actually try to create Nemesis or add Nemesis. And according to the Nemesis Hypothesis, so there is this gas giant, so we're gonna add a random where is the random gas giant? Right here. We're going to add it at a distance that we think it might actually be at. Now, it's not actually as close as you think. It's at a distance of approximately 95,000 astronomical units, which is about 1.5 light years away. So we're gonna go really, really far away. So right about here. And so here is our Nemesis, but the thing is, its orbit is very elliptical according to this hypothesis, so we need to change its orbit so that it actually approaches the sun relatively, or much closer than this, at some point. Now, the eccentricity should be about 0.7, and the semi-major axis should be approximately 95,000 astronomical units. Alright, so that looks a little bit better. Alright, so here we go. So here's our Nemesis. It's a relatively large gas giant. I'm currently made it about 12 times more massive than Jupiter. And let's look at its orbit. So its orbit is, according to the hypothesis, is quite elliptical. It's about 0.7. Ooh, it's changing. I don't know why. It's about 0.7 eccentricity. The average distance, or the semi-major axis, is about 95,000 astronomical units. Here it's 98. Let's decrease it a little bit. And also, it does approach the sun relatively close right here. Let's actually see how close this is. So if I change this to 0.7, let's see how close it gets to the sun every approximately 27 million years. And so when Nemesis is closest to the sun, when it's at its periapsis, you can actually see the orbit of Sedna. Notice how you can it's actually visible, even though it's relatively far away still. But it does make sense that there might be an object that caused Sedna to have this type of an orbit, and that basically made it orbit so far away from the sun and influence its very elliptical orbit as well. And its current distance from the sun is only about 26,000 astronomical units, so it's not actually that close either, but this would be enough for this very massive object to possibly influence some of the dwarf planets that are in the outer regions of our solar system, and to, well, first of all, cause them to have this sort of a strange orbit, but also to, at some point, when it gets so close to our sun, to influence them to basically come back into the inner solar system and possibly smack into Earth, which would of course explain the periodicity of the extinction events on our planet. So anyway, so let's play around with Nemesis a little bit more. Let's see what we can do to it. Let's see if we can actually make it a little bit brighter than this by changing its mass and increasing its mass a little bit more. I'm gonna make it into a true brown dwarf. Let's do this very slowly until it gets a little bit of temperature going. And okay, that's not, okay, there we go. So now it is a very interesting looking brown dwarf. And unfortunately, this is a little bit brighter than I wanted it to be. I actually wanted it to be a little bit similar to what we had in Space Engine, but this is the best we can do here. So this is basically a brown dwarf with temperature of about 2000 degrees Celsius. And it's not a true star yet because it's technically still a very, very large gas giant. And this is what we refer to as a brown dwarf. Now, does this object actually exist? And if it does exist, why do we actually not know more about it? Well, according to NASA and according to most of the modern scientists, it probably does not exist. And the reason why is because we actually looked for it. We've looked for it back in the 80s. We also used infrared telescopes to try to scan the entire sky looking for different brown dwarfs. And there was actually a very large astronomical survey called 2MASS, which ran for 4 years back in 1997, and it failed to detect any additional brown dwarfs in our solar system, or actually within about 10 light years of our solar system. And the most recent such search was known as Wide Field Infrared Survey Explorer, also known as WIDE survey, has not actually detected anything as cold as 150 Kelvin, or about approximately minus 120 degrees Celsius within about 10 light years of our solar system, of our planet. So even though looking at these orbits you might think there might be something out there, it's very likely that it's not a brown dwarf, because we haven't really detected any brown dwarfs out there that are within 10 light years of our solar system. But actually, the search for Nemesis is not over yet. There's going to be 2 more astronomical surveys in the next 5 years that will try to look for different cold and large objects in the vicinity of our solar system, and we might still discover it. But as of 2012, there's actually over 1,800 brown dwarfs that have been officially detected. And none of them are close enough to us. The closest one is I showed you in the Space Engine in the beginning of the video. That was, of course, Loman 16. And we also discovered that brown dwarfs are actually not as common as we thought they would be. So for every brown dwarf, there's actually about 6 to possibly even 7 regular orange sequence stars. And the majority of stars out there are basically by themselves. They're alone. So even though Nemesis would technically make our sun a binary star, so if it does exist out there, if this is actually a real object, it might make our star sun a binary object. But as of now, we realize that most stars out there are by themselves, they're alone, and most of them are very similar to our sun. They're known as the G-type main sequence stars, or you can also just call them yellow dwarfs. And this is actually a really cool view of Sedna right here in front of our solar system, and Nemesis in the distance that you can't even see, even though it's technically bright. You can't even see it because it's so far away. But look at what happens to Sedna's actual orbit. So look at the semi-major axis here and also the orbital period, and this will be in days per second. You'll notice that it actually starts changing, and that's because Nemesis actually is influencing the orbit of Sedna, which is one of the reasons why we think its funny orbit might actually have been shaped by some sort of an object that might be called Nemesis in the future, and it could actually maybe even not be a brown dwarf. Maybe it's just a very kind of a dark and cold gas giant somewhere out there that we haven't seen yet. And maybe this type of an object caused Sedna and other dwarf planets in the outer solar system to kind of have this very strange and funny orbit. Now here, what I wanted to do is this. I actually wanted to decrease the mass of this object until it becomes a relatively cold and dark place. So here we go. Now, if it was a less massive gas giant and it would be cold enough, actually at the temperature of below 200 degrees Celsius, which is what it would have if it was that far away from us, we would not be able to detect it with any of the surveys that we currently had, because this object right here is, well, first of all, it's obviously dark and cold, but it's also much smaller than the Nemesis I had before, so it would be very challenging for us to find it. And this object, if you look at Sedna again, it would still influence the orbit of Sedna. Notice how, even though it's not as fast as before, it's still increasing its orbital period, and would obviously be somewhere out there invisible to our different telescopes and different surveys that we had, and would still have quite a lot of effect on the objects in the outer solar system, also known as the Oort cloud. But nevertheless, this is still a hypothesis. It's possibly not even a reality. There might be no object at all. And actually, according to NASA currently, there's recent scientific analysis and statistical analysis show that there is possibly no actual extinction period. There might be just a statistical irregularity. Maybe there is actually no 27 million period where actual extinction events occur more often. And so for this reason, NASA actually said that there's no reason to have Nemesis anymore. It's possibly not even needed, so we're going to erase it. But unfortunately, this view that NASA has doesn't explain why suddenly have this funny orbit, and does not explain why there are actually other dwarf planets that have actually been recently discovering that also have very, very eccentric and also very, very distant orbits that would not be explained in any other way. So I personally think that maybe there is an object, and possibly not a brown dwarf, but possibly just a very massive planet or a gas giant somewhere on the outskirts here, or even farther away, that is influencing the orbits of these distant objects. And before we finish this video, let's actually launch this hypothetical Nemesis object right in the middle of our solar system and then see what happens. We're going to stop this for a second, make sure that it has just enough mass. Let's just say mass of about 11 Jupiters, and we're going to zoom in on it and watch it approach our solar system at a relatively fast velocity. It's actually going to increase its velocity with time, and then basically possibly either collide with something or cause some other damage, or might actually not even have any effect. So let's find out what happens. And here comes Nemesis approaching at a velocity of about 10 kilometers per second, but it's going to increase as it approaches closer to the sun. And you notice that Sedna's orbit starts to wobble because of this massive body approaching. And let's see what happens to all of the other planets, and also what happens to our sun if it actually changes direction and possibly causes some other trouble on our planet Earth. And we're also going to zoom in on Earth and see how it's doing after this object escapes into the outer solar system, because I don't think there's going to be any collision. I made a video previously where I kind of showed you the math behind this, and the chance of a collision happening for an object passing through the solar system is actually really low. As a matter of fact, it's almost impossible. Here we go. So here comes, I'm going to slow this down for a second. Let's look at Earth, and just to look at its temperature and stuff. And here we go. We'll fly through the solar system at a speed of about, what was the velocity here? About almost 11 kilometers per second. It actually didn't even warm up because it passed by so fast that it didn't really have any effect from the sun. But let's just leave now and zoom into our planet Earth and see how it's doing. Let's see what happened to Earth. And nothing happened to Earth. Earth is doing fine. It's a little bit more square, but that's because of the new version of Universe Sandbox 2. It's still, here we go. We're gonna go in here and optimize for climate view. Still the similar temperature as it was before. And still doing just fine. So even if an object like Nemesis passed by relatively close to us, we would probably still be fine. It might bring some asteroids and meteorites, but the chance for a collision is once again pretty low. Anyway, so this is what the idea of Nemesis Hypothesis is, and hopefully you now know a little bit more about it. Now, whether it actually is true or not, we're going to find out in the future, specifically after the next two telescope surveys that will occur in the next 5 or 10 years. But for now, we're just going to assume that it doesn't exist. And for now, at least according to NASA, it is actually not a reality. And please subscribe if you've enjoyed this video, and share this video with your friends. Like this video if you love space videos and if you actually learned something interesting from this particular video. Also check out some of the other space videos I've made and other Universe Sandbox 2 videos as well. Thank you so much for watching, and I'll see you guys in the next video. Game you later, and bye bye.